The question says 2 point dipoles of a dipole moments P1 and P2 are at a distance x from each other, and P1 dipole moment is parallel to the P2 dipole moment. What is the force between the dipoles? This is the question. So, now I have to find the force between the two tiny dipoles in space. You should know something before doing further calculations. Here is what I am showing you, the first dipole moment, okay, which is here, which is so small, possessing two charges. One is negative and another one is plus. The dipole moment of this dipole is acting in this direction, and that dipole moment is what they are calling P1 dipole moment. Meantime, we are having the second dipole somewhere here. It is also possessing the two charges. One is again minus and another one is plus, and this also has the dipole moment in the same direction as P1. That means P2 is parallel to P1, right. So, this is the condition what they have given us. P1 should be parallel to P2. So, now I am considering this as a point source or a point charge, but here this should be seen as separate. Okay. So, see this as a separate charges. Okay. See, when the dipole is taken as a very small, right, it is very small. For small dipole moments, for small dipoles, electric field at a distant point is given by E is equals 1 by 4 pi epsilon O into 2p divided by the square of the distance. Here we are using a distance x, so make it cube, and further I am finding this electric field due to the first dipole moment, that is P1. Why it is? See, here is the first dipole which is taken as a point source. Here is P1. From this we are having the second dipole, okay, whose midpoint somewhere here. This is the midpoint of P2. Okay. From here to here they are saying the distance x. So, the distance between the two dipoles means this thing. So, this is x. And now, where the 2 point charges of second dipole. So, the second dipole is having two charges like this, one is here, say minus q, and one more is here, which is plus q. Although this is a tiny dipole, I made it bigger only because to observe what is happening here. Well, the electric field at this point O is given by this equation. Okay. So, electric field at this point O is given by this equation, and it says electric field EO is in the direction of P1, that means in this direction. Okay. So, at O the electric field E is acting in this direction. This is the direction of EO. In this direction the electric field is acting. So, now this electric field varies with the tiny distance within the length of the dipole. If I call the first distance, that is minus q to 0 as dx and 0 to plus q as dx. Now, we have to know the rate of change of the electric field along this length. For that, differentiate this equation with respect to x. So, differentiate this equation, right, this expression with respect to x. So, when I make the proper differentiation, with respect to x, I may read it like this, is equals, what it becomes, minus 1 by 4 pi epsilon O into, it is 3 into 2, it is 6 P1 divided by x to the power 4. This will be the result along with dx. Okay. So, this is the rate of change of electric field with respect to the distance. This is what I did, and I simply found dEO, that is change in the electric field with the distance dx. Now, what I have to find is, see this dipole now apply different forces on minus q and plus q. Okay. Forces on minus q and plus q are different. Okay. The forces on minus q and plus q are now different. For that, I first calculate how much is the force on this one. On this one, since it is negative charge and the electric field at this point is acting in this direction, and the change is what we observed here, right. So, this much change we see, that means why we are getting negative, as you move away this much electric field will decrease for this distance. That is the meaning of this equation. That means when you come towards negative q from O, this much electric field will increase, right. So, this much electric field will increase as you move from this point to this point. The formula for the force is electric field into charge, otherwise charge into electric field. This is what we can make use. So, now I call a force F minus, which is here, right, F minus, which is acting to the left, because this electric field will attract this negative charge, whereas this electric field at O will repel this electric charge, which is plus q, right, plus q. The symbol was right, okay, let it be. So, this is a F plus force. Now, what I have to find is, now F minus is, this is equal to, what I should write, charge, only I consider the magnitude of the charge, that is q, okay, into the electric field. So, at this point the electric field is not EO, the electric field must be EO minus dEO. Now, so as you move here it becomes plus, right. So, that much electric field will add up. Meantime, when you think about F plus, that means you are moving away from this O, this much electric field, that is dEO, will decrease. That means q into, why I am taking q, this is the magnitude of this charge, which is multiplied by, it is EO minus dEO. So, now we have to find the net force on the dipole, right. That is what I need finally, net force on the dipole. So, that is F is equals F minus and F plus. One thing you must know, F1, the magnitude of F1 is greater than magnitude of F2, right. So, F1 is more, and that means F minus is more. So, I should not use F1 and F2. So, I should use terms like F minus and F plus. So, F minus is more than F plus. Okay. So, for that reason the net force will be in this direction. Okay. So, this is the direction of net force F. So, net force that is acting in this direction. So, that means what I have to do, F1 minus F2 should be written. So, now simply make substitutions. What is F1? F1 is this much, which is q into EO plus dEO, right, minus q into this much, which is EO minus dEvo, that is F is equals, when you make it open this bracket, this becomes this thing, you know, plus Q into dEvo. So, minus Q EVO plus Q EVO, these two things get cancelled and the remaining terms will add, that means 2Q into dEvo. Now, make substitutions. So, F is equals to Q into what is dEvo? dEvo is having only the magnitude, I simply put the magnitude of dEvo. Okay. So, magnitude of dEvo is simply 1 by 4 pi epsilon O, okay, 6 P1 divided by x to the power 4, which is here, right, into dx, into dx. Now, by definition of dipole moment, P2 is nothing but the dipole moment of the second dipole, right, which is nothing but what, which is the magnitude of either charge, whether it is minus q or plus q, whatever it is. So, I simply take charge and multiplied by the distance between the two charges. Distance between the two charges is written here, that is dx plus dx. So, this total distance becomes 2 dx, right, this distance, that is 2 dx. Now, observe 2 is here, dx is here, right. So, 2 dx into q, 2 dx into q. So, this one and this one, when they merge, they give P2. Then what I can write for F, this is 1 by 4 pi epsilon O 6 P1 dx into 2q is P2 and whole divided by x to the power 4. This is the magnitude of this force, right, and this force, net force, is acting in this direction, this is acting in the reverse direction. So, for that I can simply say this is a F into, right, minus x cap, this will give the direction. So, this is the completion, that is, this is our final answer.